In lesson 24, we're going to look at some word problems and situations and come up with a piecewise equation for each of the domains. Now, you know, from piecewise, you're going to have different segments that belong to a different equation. And so that's what we're going to be looking at and how they apply to word problems. Now, in Algebra 2, you're going to get to see more of piecewise, but in here, they're all going to be linear, so you don't really have to worry about exponential equations here. All right, let's start with this problem. We have two types of parking lots. At any time, you can pause this video to make it go slower or faster at your own pace. I'm going to start with the blue line parking. We have to evaluate which parking situation would be better if I'm going to stay for 5.25 stays at the parking structure. So for the blue line parking, we see that from hours 1 through 5, they're going to charge me $5 flat. Anytime after that, it's going to be $4 an hour. So like for hour 6, it's going to be $5 flat plus the 4, and then it goes on like that for hour 7 and so on. Now, I immediately identify that there's going to be this specific domain. So from hours 0 potentially to 5, and that's where I made a mistake here, the cost is going to be $5. So that's y equals 5. Now, anytime you hit 5 point something, so if x is going to be greater than 5, then I'm going to be dealing with a totally different equation because I have to add that $4. So it's going to be 4x plus 5. And that is our first piecewise equation. Now, to answer the question, how much would this be for 5.25 hour stay, you have to plug it in. Now, which function do you plug it in? Well, because it's more than 5, then you would have to plug it into the second equation, 4x plus 5. In this case, it gives us the cost of $26 for the blue line parking. Let's go ahead and try our equations for the 1, 2, 3 parking lot. It seems really complicated. We have, let's see, $6 for the first hour or part of an hour, $5 for the second hour, $4 for each hour after that, starting with the third hour. Okay, so hour 1, or actually hour 0 point anything to hour 1, is going to be $6. Then as soon as I hit that second hour, it's going to give me whatever the 6 was plus the $5, giving me a total of $11. And then for the third hour, it's going to be my $11 that I had before plus 4 for an additional hour. Let me clear my head real quick. I have 3 different segments here. Anywhere from 0 to 2, that's going to be $6. Now you have to understand, piecewise, during that domain, they're going to be continuous. So it could be 0.1, right? 0.1 of a minute is still going to cost you $6. My second segment is going to be from $2 to $3. That's going to be 11. And then from 3 hours on is going to be 11 plus the $4 and times x, depending on how many dollars. So how many hours I stay there. Okay. So we have 3 different segments. The first one is y equals 6. There's no rate of change there. No matter how many hours you have, you're going to be $6. The second one is going to be 6 plus 5x. And the third one is going to be 11 plus 4x. So to answer the question, which one is cheaper? Now, I went ahead and accidentally deleted all my other equations that I had. But if you're taking notes, you'll have them in front of you. So I'm doing the math for the 1, 2, 3 parking. And I'm actually making a mistake right here because I should not be plugging in the 5.25 since I've already charged 6 and 5 for the first and second hour. So it should actually be times 4. Either way, it would end up being 27. And the blue line is going to be cheaper at 26.